Hi, I'm DJ Ware. On this episode of the CyberGizmo, we're going to be looking at Flatpak, AppImages, and Snappy right after this. It seems like every time the topic of containerization comes up, or jails, or virtual machines comes up, these three topics come up right along with it. And all they do is add confusion. So what I'm going to try to do is try to break through some of that confusion and tell you exactly, as far as I know, each of these three operate, what they do, and what they're good for. So, let's start with Flatpaks. Flatpaks were created in 2015, so they're pretty new, about 5 years old. They originated from Red Hat's XDG app, which was the first kind of containerization of applications within a virtual sandbox. A sandbox being a kind of a protected environment in which you can install an application. It's kind of a fence around the application, and the idea behind a real sandbox is to prevent it from communicating at all with anything in the host environment. So it can't communicate with libraries, it can't talk to applications, it can't use parts of the Linux kernel that are inside of the that are outside, of the sandbox. So it has to be sort of self-contained in the purest form of sandbox. But as you'll see, there's some things that these do. So Flatpak has deep integration with GNOME and KDE. Other desktop environments, not so much. So we'll talk about some of the other things about it. But Flatpak should still work even after there's an update to the core OS, because that's kind of their feature in what they call their forward-moving system. So it allows the core OS and utilities to be updated independently, even though the Flatpaks themselves may be behind a version. So those continue to run. Flatpaks can be distributed from a user or developer site, but they also maintain the Flat Hub. And that is really a central repository. So it's up there. The users can do it themselves, or they can install their apps within the repo. Sandbox is provided by Bubble Wrap, and Bubble Wrap has been kind of popular in some of the Linux systems to try to act or mimic what Jails does under BSD, or more accurately, FireJails. But it's an interesting technology. It's an interesting architecture, and we'll dig into it a little bit. The Flatpak sandboxing does and can exchange information with the host OS. Oops. So, the whole definition of a sandbox is to try to insulate and isolate the app from the rest of the world. And I suppose in order to get to be able to function, it has to talk to the host OS. And that's unfortunate, because that really allows us to inject malware into the system. And as you'll see, that's not common to just Flatpak. But the Flatpak does and can allow multiple versions of the same application to execute simultaneously. So if you're bringing up a new application for the first time and you want to maintain the old one and you want to test on the new one, you can do that. You can leave your old application running and not disturb it. It's kind of nice. AppImages were created in 2004. Their mantra is one application, one file. So everything you need is encapsulated within the app image itself. It originated from a project called Click, and that allows the applications to run almost on any Linux system that's out there that I know of. I think it's almost any. And it offers the ability for those applications to be installed without having to have root access. Unless, of course, you want to put them in a global location and share them between multiple users. But if you're installing AppImages under the user account, then you don't need root access to do that. It has no effect whatsoever on the host operating system, nor does it care what the host operating system is doing. The developers can make app images for any particular version or particular version of an application. So here again, AppImages could allow multiple versions of the same application to run. But the other kind of cool thing about AppImages is you can put them on a USB stick, and you can take them with you and use them. So yeah, and it doesn't matter. You don't have to take your whole system disk or anything else. You can just take the app image. It's a file. You just copy it. And the only thing you have to do to get the file to execute is just chmod it to give it execution rights, or go into your file manager and click the execution bits on, and it'll run. The app images can be run on servers, but it's in a limited fashion. Servers don't have GUIs, and app images are really more for desktop kind of applications. But you can, there are a few that run using the CLI tools. But the other thing is that you can use the app image kit, and you can take any application on your system and turn it into an app image. Not bad. Like I said, it also allows multiple versions to run simultaneously. Snappy, it's going to take a little bit longer to explain because it's a little bit more complicated. It was created in 2014, and it is a unified single-format software package. It originated out of Ubuntu Touch. This is my understanding. Snap is the file format of the packages, so it has its own special format. Snaps are all-inclusive. That's similar kinda to AppImage. I'm not going to say it's exactly like, because it's not. It's kinda, and you'll see what I mean by kinda. Snapcraft is the tool to make snaps out of the application. So typically that's a developer thing that they have to do. I mean, I suppose you could probably figure that out yourself, but it would probably take some work on your part. Snapd is the background daemon that maintains all the snaps that are installed in your system. So if there's an update to a particular snaps, then that automatically takes care of it, and it applies it whether you want it or not, as long as that daemon is up. If you don't want automatic updates, turn the daemon off. Snap Store is the Snap Central repository. It has major support from Google, Microsoft, and Mozilla. There's some others as well that are doing it. Users can snapshot apps to create, to save off a current state, and with that current state, it also saves your current configuration. So, but if you do a snapshot, as I understand it, it does all of them at once, not just by the application. I'm not sure about that. I'm not an expert in snaps, but have heard from other users that it does the whole thing. You can continue to use the applications as they're being updated, and you can reverse out an update if you need to. So if there's something that doesn't work right, you can reverse it back out to an older release. It uses, I'm putting the sandbox in quotes because, again, a sandbox is, by definition, means that it is basically jailed and you cannot access any of the host applications or resources. But they use a sandbox-like approach using AppArmor, and that offers a classic, strict, and dev mode. Each level of access permits different levels of access to the file systems and to the computer, the host computer that they're talking about. So host-based file access and host-based computer resources. The other problem is that with it is that X11 desktops, at least as far as I know, and the last time that I've seen a review of this was last year, they will not support isolation that's used by Snappy. So so all those nice features, excuse me, get down. So as of the last time I've seen this review, that it doesn't do any good, because if you have X11 desktop apps, they bypass the model because they don't support AppArmor. The Snap Store is closed and proprietary, which has been a common complaint about snaps. And then you can currently, as of the time I'm making this video, you can only have one version of the application running at a time. So you can't have the old version running and then install the new one. And the reason for that is that Snaps does Delta updates. So it takes your old application and updates it using Delta updates and then starts it running. So there is an outage there that occurs during that update because there's a switch that causes an outage. You can't update code on the fly into memory that has been allocated. Sorry, Ubuntu. That magic, as far as I'm concerned, hasn't been invented yet. You're going to have to pull something out to put something in. But There's an experimental feature that's called parallel install, which is supposed to allow multiple versions of the snaps to be created and executed at the same time. So I suppose with that, I'm not quite sure how that works. Haven't experimented with it much, and so I'll probably come back to that at some point and look at that. But like I said, it's experimental. So let's take a comparison and go kind of across the three to kind of get an idea of how to compare and contrast all three of these. So the unique feature about AppImages is that it's not an app store and it's not a repository. It's simply a package format for an app, so for software distribution. So it's basically an app in a box. So you take the app image, you install it, you add executable permissions to it, and boom, you're done. Snappy is, of course, led by Canonical. That's the same company that publishes Ubuntu. It features a central app repository and has active contributions from Canonical as well as other third-party. But I believe they have to sign a release in order to do that. Flatpaks feature an app store called FlatHub. However, developers can host Flatpaks on their own site. So you don't need a repository to post the Flatpaks. You can host them on their own site, just as you can with AppImages. The target systems for AppImage and for Flatpaks are desktops. Now, for AppImages, you can run those on servers. In the case of Flatpak, it's limited because it has to use the CLI, and some of them will not work. Snappy, by contrast, will do desktop servers, it does IoT, it does embedded devices, so it has a pretty wide range of support within it. The libraries and dependencies for AppImage, its base system runtimes are optional. The libraries and other dependencies have to be inside the package, or should be, by definition of a sandbox. And then you have in Snappy, the base system via plugins can be packaged. Now, we already know that there's communication that can occur out of Snappy. Same with Flatpak. GNOME, KDE, free .step bundles or custom bundles are inside the libraries. The initial releases, we talked about that. Sandboxing can be implemented in AppImage, but it's not required. Snappy has 3 modes, so we'll talk about those. Strict, Classic, and Dev mode. There's various confinement capabilities and runs in isolation, quote, unquote. The Flatpaks are isolated but use the system files and to run applications by default. Okay. And then the types of sandboxing that's available under AppImage. You can use FileJail, AppArmor, Bubble Wrap. On Snappy, it's only AppArmor, and on Flatpak, it's only Bubble Wrap. Now, Bubble Wrap's okay. It's not a bad thing. As far as application installation, it's not necessary. You don't have to do anything other than download it and then change it to executable for AppImages. For Snappy, you install using well, snapd has to be running, but you can just use the snap command to download and install it. Flatpaks are installed using the Flatpak client. As far as app execution, you set the execution bit on AppImages and they run. On Snappy, the desktop is integrated using Snap tools. It runs isolated with user-defined resources. Flatpak needs to be executed using the Flatpak command or the CLI commands. User privileges on AppImages, you don't need root access. On Snappy, it can be used with or without root access, but again, this depends on the file system. Typically, you are going to install with root. Flatpak selectively required, depends, right, on what the needs of the apps are. Hosting applications on AppImage, you can put them anywhere you want by anybody. So good and bad there, right? If you're trying to control a desktop environment and you have users downloading AppImages, they can bypass any kind of conformance policies that if you're in a corporate environment, you could bypass any of those policies that you have in place. Snappy has to be hosted on the Canonical servers. We talked about that. Flatpak can be hosted anywhere, but they also maintain a repository called FlatHub. Portable execution for non-system files, yes, AppImage can do that. Snappy, no. Flatpak, yes, after the Flatpak client is installed. So you can put those anywhere you want. Even in non-system locations. So you can put them in your home directory and you can run them. Central repository, there is an AppImage hub. Snappy has the Snap Store, and we talked about FlatHub already. Can you run multiple versions of the app? Possibly an app image, depends where you put them, where you have them at. But yes, in theory, yes. Snappy, one version of the app per channel. Has to be separately configured if you want to do more, and it requires this experimental piece of code. I don't know if that's actually gone into production yet. Don't know. Flatpak, yes. Updated applications. You update app images using the CLI command, app image update. Snappy requires snapd installs, supports Delta updating, automatic updates. And that the only way to get rid of automatic updates is turn snapd off. Flatpak requires Flatpak install apps and updates are using the Flatpak update CLI command. Package sizes, the application remains archived, so it stays inside of the archive, and it runs from inside there. Snappy, applications also remain archived. And then the Flatpak, the client side is uncompressed, so just part of it is uncompressed. So all three of these solutions are really to address installing applications in a platform-agnostic way. They are not containers. They are not virtual machines. They are mechanisms to package applications to allow them to run on a machine, and it doesn't matter if it's Debian or Ubuntu or Red Hat or Arch. It doesn't matter. That's the idea behind this, is to come up with a one package solution that will run anywhere. Snaps offers the widest choice of hardware. So these are some of my conclusions from looking at this. AppImages and Flatpaks are more for desktop users, less value to the system user or the server user. AppImages for popular applications have smaller package sizes and offer better portability. That's an opinion. Flatpak is really good. It has its forward compatibility, and if you use it in a set and forget mode, it works really good. I have a number, but I know a lot of people have had problems with Flatpaks in the past. But none of these are virtualization or container solutions. So when people start talking about containers or virtualization, these have absolutely nothing to do with it. It's not even close. A Flatpak, on the other hand, does have the ability to run in a container, and it could be containerized if you wanted to. But they don't really want to talk about that so much on their site. I don't know why that is. Maybe there's some, because of the way that it communicates outside of the sandbox. They don't really want to talk about that so much, but it could, in theory, be considered a container solution, but the Flatpak folks say, no, we don't want to talk about that. Sandboxing in general is a flawed concept. That goes all the way back to a long time ago. It's why we don't use sandboxes too much, because there is always data that has to flow between the host OS and the sandboxes. Who owns the hardware? It's the host OS. So, yeah. So there's always that problem. So anywhere there's a flow of data, there's a potential for a security breach of the host OS. And because if it flows in, it can flow out. It's just the way it works. And so, yeah, you could, in some of these, because the users, like AppImage, you can create your own. You could be creating your own malware and injecting it into a lot of different people's systems. Great. These solutions are meant to offer, like we said, platform agnostic approaches. Snaps must use the libraries from within its own Snaps package, meaning that that's up to the developer then to keep the packages that are system packages up to date within the Snaps that particular application needs. And that introduces a potential security risk, because if I've got, let's say I've got, I don't know, let's say we have 10 or 15 Snap apps on a system, and they're all maintaining different versions of the libraries, and there's a vulnerability to those, then I've got to have the person that's responsible for that Snaps to update the library inside of the Snaps package and make sure it's deployed. I don't know how the heck you track that within the system, and I think that's going to get very complicated, and it's a potential security risk. So for me, I don't like any of these options. Sorry, I don't. I just don't like the idea of sandboxing, and that's just a preference of mine. If that doesn't bother you, then great. I'd love to hear which one of those you like. So with that, I hope I hope you enjoyed this today. Very short, just trying to clarify what these do and hopefully try to reduce some of the confusion when people are talking about containers and virtual machines, because none of those are. Hope to see you again real soon, and bye for now.